Let's continue with Fibonacci numbers and the golden ratio. So I'll be reading this part and emphasize just the important parts, the highlighted words, and those who are which are possibly coming out in our quiz. Fibonacci numbers is a list of integers that starts with 0 or 1, followed by 1, and proceeds with enumerating the rest of the elements based on a rule that each element is the sum of the preceding two integers. The list is named after Leonardo Pisano Bigolio, also known as Leonardo Fibonacci, an Italian mathematician who wrote the book Liber Abaci in 1202. The book contained Leonardo's description of Hindu-Arabic numeration system, a number system which, he explained, is more significant and efficient than the Roman numeration system used in Europe at that time. Okay? Hindu-Arabic numeration system. So, Leonardo is also one of the proponents of um, another numeration system because he observed that Hindu-Arabic numeration system is more significant and efficient than the Roman numeration system, which is used in Europe at that time. The book also contained a problem that concerns the birth rate of rabbits. So this is common when it comes to Fibonacci sequence. So that concerns the birth rate of rabbits. It is this problem which gave rise to the Fibonacci numbers. Okay, so this is the Fibonacci spiral. In this figure, you can see 1 and 1, 2 and 3, 2 plus 3 is 5, 5 plus 8. If we continue with the spiral, the next part will be 13 and so on. The ratio of the longer side of the rectangle to the shorter side is A plus B over B. And this ratio is replicated in all smaller rectangles. The ratio is close to the ratio of two consecutive numbers in a Fibonacci sequence. It is denoted by these Greek letters whose value is 1 plus square root of 5 over 2, and it is approximately 1.618. The sequence of numbers in the Fibonacci sequence describes the population increase in rabbits for n months. He discovered that the number of pairs of rabbits for any month is the sum of the numbers of pairs of rabbits from the two preceding months. So, it is how the Fibonacci sequence was discovered. His name Fibonacci is short for Filius Bonacci, meaning son of Bonacci. This is Leonardo Fibonacci, 1175 to 1250. He is an Italian mathematician from Pisa who popularized the Hindu-Arabic number system in Europe through his book Liber Abaci, Book of Calculations. He also wrote Practica Geometriae Liber Quadratorum, Book of Squares, and a book on arithmetic used in commerce. He is most famous for Fibonacci sequence. Many mathematical concepts were discovered to be linked with his sequence. So here's the Fibonacci numbers. F1 equals 1 and f of 2 equals 1 and f of n equals f of n minus 1 plus f of n minus 2 for n greater than or equal to 3 where n is a positive integer. Why? Because in this part, ang f1 and f2 is already considered equal to 1. So you will start calculating the value fn from 3. Okay? So example, if we say f of 8, So f of 8 is equal to 8 minus 1 and 8 minus 2. What is the value of f in that series? So that would be the equivalent number of f of n. I'll be showing that later. So we have also the golden ratio. Euclid's book Elements gives the first written definition of what we take to mean the golden ratio. A line segment is said to follow the golden ratio if the whole line is to the greater segment as the greater is to the lesser. Again, a line segment is said to follow the golden ratio if the whole line is to the greater segment as the greater is to the lesser. Okay. Given a line segment which is the sum of A and B where A is greater than B, the segment follows the golden ratio if the ratio of A plus B to A is equal to the ratio of A to B. The golden ratio is also called by other names. We have golden mean, golden proportion, golden cut, divine proportion, extreme and mean ratio, and medial section. So notice this is how we solve the golden ratio. We show the golden ratio. Okay, in this figure 24, the golden ratio. The ratio of the entire line segment to the longer segment is equal to the ratio of the longer segment to the shorter. That's what it means with the statement here. The whole line is to the greater segment as the greater is to the lesser. Okay, so it is also called, okay, I have already mentioned that 3 times or 2 times before. One captivating discovery about Fibonacci numbers has to do with its connection with the golden ratio. If we take the ratio of two consecutive Fibonacci numbers, this ratio progressively comes close to the value of the Fibonacci as n increases in value. Example, if n 1, 2, 3, 4, 5, 6, 7, 8 up to 12 and f of n equals, so when we substitute 1 and 2 in n, the value of the Fibonacci number is still 1. But if we put 3, the value of f of n is 2. If n is 4, the value of f of n is 3. If n is 5, the value of f of n is 5. If n is 6, the value of f of n is 8. And if the value of n is 6, the value of f of n is 13. And so on up to 12 in this illustration. So the ratio, the golden ratio, okay, 2 is to 1, 1 to 1.5, 1.6, 1.6, 1.6. If you notice, as we approach to a higher value of n in this sequence, it reach into the golden ratio. The golden ratio is embedded in many geometric shapes with an enduring aesthetic appeal. Some artists deliberately set the proportions of their pieces according to this ratio. Example is Salvador Dali. Used the golden ratio in many images contained in the Sacrament of the Last Supper. Famous Swiss architect Le Corbusier, the architect who designed the United Nations Secretariat building, centered his design philosophy on harmony and proportion based on the golden ratio. And I believe so much of our designs and architectural innovations this time are also based in the golden ratio. So Salvador Dali and Le Corbusier. Salvador Dali painted the Sacrament of the Last Supper, and Le Corbusier designed the United Nations Secretariat building. So this is the figure of the Sacrament of the Last Supper by Salvador Dali, and this picture is from the National Gallery of Art in the United States of America. So notice how this picture, yeah, it's very symmetrical and it follows the golden ratio. We have also what we call the golden rectangle. The golden rectangle, golden triangle, and the golden angle are three geometric shapes known to contain the golden ratio and are among the reasons behind the aesthetic appeal of many artistic pieces past and present. We could not be certain, however, if great artists from distant past deliberately used the ratio to set the proportions of their art, since no explicit written accounts of that had been discovered yet. Some psychologists suggested that we may have an unconscious grasp for the aesthetic appeal of the golden ratio because our brain has evolved to be keen to this proportion, according to Bedjan 2005. As far as the golden rectangle is concerned, for example, the human eye is quick to grasp its shape because the human eye is oriented towards the horizontal. Between 3 and 2 million years ago, early humans, Homo erectus, left the forest to occupy the vast plains of East Africa. Some 1.9 million years ago, they migrated out of Africa, and succeeding species of early humans continued with this migration. Their new environment, which is the wide and open field, selected a type of eyes adept to take in visual stimuli that were oriented horizontally. This is the reason why humans are oriented to visual cues, which are horizontal and rectangular, because this is the field of vision humans see when they scan the wide spans of land right in front of them. But what about the proportion in the golden rectangle? This is the golden rectangle. If you notice, we can also see the outline of the Fibonacci sequence, and this is the Fibonacci spiral. And if you notice, there is the golden ratio 1.618. So the golden rectangle is a rectangle with side lengths that are in the golden ratio 1 is to 1.618. The aesthetic appeal of the ratio itself has to do with balance, and in this particular instance, it is the balance between symmetry and asymmetry, or between order and chaos. If the rectangle has four equal sides, then it is simply a square. A square is symmetrical along the diagonals and along the perpendicular lines that run through the intersection of the diagonals. A square is a design that represents only symmetry and order. The asymmetry of the golden rectangle, on the other hand, provides enough disturbance which renders it out of balance, but not too much out of balance that it become chaotic. The golden ratio, or the golden proportion, represents the ideal balance between order and chaos, between symmetry and asymmetry, between stability and movement. That is from DeVries M 2012. In addition, the golden ratio abounds in nature. It is found in plants, in the vertical distribution of leaves and branches, for example, and in human anatomy, to name a few. It is possible humans are absorbing this is stimulus unconsciously, or maybe it is already in the unconscious mind, and this affects their standards for judging what is beautiful and what is not. The golden angle is created by sectioning the circumference of a circle according to the golden ratio. It is sectioned into two arcs such that the ratio of the length of the longer arc A over the shorter one B is equal to the ratio of the entire circumference A plus B over the longer arc C. A. The golden angle is the angle subtended by arc B and is approximately equal to 137.5 degrees. Take note of that. The golden angle is seen in the morphology and development of plants, in the arrangement of leaves on a stem, and in the arrangement of florets in an inflorescence. The sunflower, for example, is a collection of florets. The study of the arrangement is given a special name in botany, and they call that phyllotaxis. Okay, it is derived from the ancient Greek word phyllion, which is leaf, and taxis, arrangement. So look at this figure. The vertical distribution of branches of plants mimics the Fibonacci sequence. You can also observe that in maybe the trees and the plants around you right now, if this is true. Okay, and then we have also the golden triangle is an isosceles triangle where the ratio of the leg to the base is 1.618. The vertex angle is 36 degrees and the base angle is 72 degrees. A pentagram. You always hear, or maybe you have heard about the pentagram. A star where the corners are golden triangles. It can be constructed by inscribing a regular pentagon in a circle and connecting opposite vertices to form the pentagram. So that is a perfect star. You draw a regular pentagon. When we say regular polygon, it means that all sides are equal. So regular triangle, regular pentagon, regular hexagon, regular heptagon, all those means that their sides are equal. So if you are asked to draw a regular polygon, ask them how many sides, then all the sides should be equal. So the pentagram, notice all these figures and distribution of the measures of degree. So 36, 36, 36, 108, 72. There are supplementary and complementary angles here. This is the golden triangle and this is the pentagram. Okay, so the golden angle follows A plus B, and this is A and this is B, and it makes the golden angle 137.5 degrees. So botanists had observed that leaves do not sprout randomly around a stem. Their distribution follows a pattern. They appear around the stem such that each leaf receives the best amount of sunlight possible without completely blocking other leaves. This is achieved when each leaf appears at an angle away from the rest of the leaves. That angle is the golden angle, which is approximately 137.5 degrees. I like how it is said. No? They appear around the stem such that each leaf receives the best amount of sunlight possible without completely blocking other leaves. So try to observe some plants in your garden or your mother's favorite plant and observe how the leaves are arranged and notice that each of them has um, a chance to what? A chance to receive enough amount of sunlight, best amount of sunlight, so that they can continue processing the photosynthesis. So that is the part of the Fibonacci sequence and the golden angle, the golden ratio, the golden triangle, and what else? The golden angle, triangle, and the golden ratio. So the golden ratio is 1.618. The golden angle is 137.5 degrees. The golden triangle has 72 degrees on each base and 36 degrees in its vertex. So I hope you will not forget that. We have the term phyllotaxis here from the Greek word phyllion and taxis, leaf and arrangement. And yeah, the golden rectangle has 1 is to 1.618. That means enough symmetry and asymmetry, enough stability and chaos, no? So that is the golden rectangle. And I believe so that this is imbued to us humans. We are imbued with that concept of uh, the golden rectangle because we can really view. And if you notice, you can apply this in photography. The rule of thirds, yeah, it can be seen here, 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 and here. So that is that is all for this part. I will continue with the next part later.